Welcome back, developers. Let's jump right into today's explainer because we're tackling a massive challenge in the decentralized web, and that's privacy. We're getting straight into a hands-on how-to guide for safely locking away your sensitive data using Lighthouse and the Kavach Encryption SDK. If you're building Web3 apps, you absolutely need to know this. So let's just get to it.
IPFS is incredibly resilient, right? But out of the box, standard IPFS is literally like a giant global transparent glass bulletin board. Whatever you pin up there, the whole world can see. But what if you could stuff your files into a titanium lockbox before you pin them to that public board? Imagine getting all that amazing resilience of decentralized storage, but keeping the absolute privacy of enterprise-grade encryption.
Just look at the stark contrast here. Standard IPFS is public, transparent, and totally exposed. Then you look at the Lighthouse solution, encrypted, sharded, and incredibly secure. Lighthouse is honestly a game changer here. It protects your data while still letting you tap into the raw power of decentralized storage. Here's our roadmap for this explainer. 1. The public network problem. 2. Introducing Kavach. 3. Gathering developer tools. 4. Signing the authentication message. And 5. Uploading encrypted files. We'll go right from understanding the vulnerability to actually executing an encrypted deployment. All right, section 1, the public network problem. Let's quickly frame up the vulnerability before we go and fix it. So the core issue is that anyone across the globe can view files uploaded to standard IPFS just because of its public nature. Imagine uploading a user's health record or maybe a proprietary smart contract only to realize that literally anyone with a hash can download it. If you're uploading sensitive user data or confidential assets without protection, you're basically broadcasting them on a global loudspeaker. It's an awesome feature for public data, sure, but a massive vulnerability for anything private. Okay, section 2, introducing the Kavach Encryption SDK. This is your shield against the Wild West of the public network. Now, Kavach literally translates to armor, and that's exactly what it is, an unbreakable shell for your data. It's an encryption SDK built entirely by the Lighthouse team. It uses distributed key shards and threshold cryptography to secure your decentralized applications. To put that into perspective, it basically shatters the encryption key into pieces, so there is absolutely no single point of failure. None. And that is a massive advantage for Web3 developers. These features show exactly why Kavach is just so developer-friendly. It's got randomized key shards, private key support, seamless key reconstruction, but look at those last two. Strong TypeScript support, which, let's be real, we absolutely crave to avoid those nasty runtime errors, and optional 5-node redundant storage. That means your encryption key shards are distributed across 5 different nodes. It's massive out-of-the-box redundancy. Moving on to section 3, gathering your developer tools. Before we write the actual deployment, let's get our toolkit sorted. To actually use Lighthouse Encryption, you are absolutely going to need these 3 things. Step 1, an API key. Step 2, your wallet's public key. And step 3, a signed message. That signed message is super important. It's how you authenticate your identity without ever exposing your private key. Thankfully, you can set all this up right in your terminal. Just run a global npm install for the Lighthouse Web3 SDK. Once you have that CLI tool, you just run Lighthouse Web3 wallet and Lighthouse Web3 API key. That's it. It generates your API identifier and hooks up your wallet public address. The CLI literally does all the heavy lifting for you. Section 4, signing the authentication message. This is a critical step, proving you are who you say you are. Now, to do this securely, you really need to keep this authentication entirely server-side. Go ahead and install ethers.js. By signing on your server instead of the client's browser, you make sure your private key is never, ever leaked into the front end. Think about it. If a bad actor scrapes the private key from your client-side code, your whole system is compromised, right? So keeping this in a secure backend environment is just non-negotiable. So functionally, here is what happens. Your server fetches an auth message from Lighthouse using your public key. Then, using your signer in ethers.js, you securely sign that requested message. You don't need to overcomplicate it. It's basically just a digital handshake that cryptographically proves your identity. Finally, section 5. Uploading your encrypted files. It's execution time. Time to lock that box and pin it to the board. Here is where the magic happens. You're going to use the upload encrypted function. You literally just pass it the path to your file, your API key, your public key, and that signed message we just made. That's the whole shebang. The Kavach SDK takes over, slaps on that final cryptographic lock, and routes your encrypted data out to the IPFS network. Quick pro tip for you though. What if you're not uploading a file but just some sensitive text? Well, you just use the text upload encrypted function instead. The parameters are exactly the same, but you pass your raw string data directly into the function instead of a file path. It's incredibly flexible. Okay, so wrapping up. Security in a decentralized environment is complex, but it's absolutely crucial. Tools like Kavach do the heavy lifting, for sure, but the responsibility to actually implement them, that's on us. As developers, we are the gatekeepers to our users' privacy. So now that you hold the keys to decentralized privacy, what are you going to secure first? You've got the how-to guide, you've got the SDK. You can finally ditch the transparent glass board and use the titanium lockbox. In a Web3 world where data is permanent, what are you going to encrypt first? Dive in, get those API keys, and start building. Happy coding.